In the last lesson, we were identifying lines in the coordinate plane, and as part of that, we were identifying their slopes. This first part of this lesson talks about lines that are parallel. And if the lines are parallel, their slopes are the same. Here it says if we start by saying the lines are parallel and they're non-vertical, then we know that their slopes will be equal numbers. Now, the converse of that is if the slopes of two distinct, meaning they're different lines, they're not the same line, named differently, and they're non-vertical. If their slopes are equal, then the lines are parallel. So essentially what this is saying is if they're parallel, the slopes are equal. And if the slopes are equal, the lines are parallel. It's a if and only if situation because this is the conditional statement and this is its converse, and they're both true. Now they say non-vertical, okay, because any two vertical lines or horizontal lines are parallel. Vertical lines actually have undefined slopes, so we can't set that equal to another slope because it doesn't have a number, it's undefined. That's the only reason that it says non-vertical. We can still have vertical lines that are parallel, okay? And in fact, if they both have undefined slopes, then they're parallel. If they both have zero slopes, then they're horizontal lines and they're parallel as well. Now in this first problem, we are checking to see are these lines parallel. So it says are lines L1 and L2 parallel and explain. That's these two lines. Are they parallel? Well, really, they look it, but can you tell from a diagram just by looking at it whether the lines are parallel? And the answer is no. The lines may look parallel, but you only see a small portion of their graphs. And essentially what it means is if you extended them into infinity in both directions, would they eventually cross? Hard to know if it's pretty close to parallel. So the only way we can know is by comparing their slopes. So let's do that. We find the slope of each line, we take the 2 points, and we do the change in y over the change in x. Okay, change in y over the change in x. And when we do line 1 here, we see that it's got a slope of -3. And this line 2 has a slope of -7/2, which is actually -3.5. Those numbers are close, but not the same. And so these amounts are not equal, and so the lines are not parallel. And in fact, you can see down here, if you look closely, that these points here are 1, 2, 3 units apart exactly, right? And as you start to get higher, you can see that 1, 2, not quite 3 before you get to that next line. So they're getting closer together as we go higher for y, okay? That's not how you should do it. You should do it by this, but I just wanted to demonstrate you can see that. Now, you have a got it problem? Are the lines that contain A and B, this L3, and line L4 containing C and D, are they parallel? So here, problem 2, they're asking us to write an equation for a line parallel to this line. What is the equation of the line parallel to this line containing this particular point? Well, how does it help to know what the equation of the other line is? Well, parallel lines have the same slope. And so if they give you this equation, and you know that this one has a slope of -3, then we want our line to have a slope of -3 as well. And so now we've got the slope and a point on the line. So what should we use? We should use point slope form. Okay. Taking their equation again, they identify the slope. We're going to use point slope form, put the slope in there, put the x coordinate there and the y coordinate there, and then we just have to simplify this part. And that's it. Try it with this point, and this line parallels to the line that you want to draw the equation for. Okay, so when lines are parallel, their slopes are exactly the same. When two lines are perpendicular, it says the product of their slope is -1. And essentially, if you want to get a product of -1 by multiplying two numbers together, the numbers are opposite reciprocals, okay? So what that means is you invert it, you take the reciprocal of it, flip it, and you use the opposite sign, okay? So here again, it says if two non-vertical lines are perpendicular, the product of their slopes is -1. And the converse of that is if the slopes of two lines have a product of -1, the lines are perpendicular, right? So it's an if and only if situation. Now, any horizontal and vertical line are perpendicular. Why does it have to be said like that instead of product of -1? Because horizontal lines have a slope of 0, and anything times 0 would be 0, but vertical lines have an undefined slope. So essentially what you'd have to do would be 0 times undefined. That doesn't make any sense. So we just know that if it's a horizontal and a vertical line, 0 slope, undefined slope, definitely perpendicular. Any other two lines will be perpendicular if when you multiply their slopes together, you get -1. In this problem, they're starting by telling us that there are two lines here, L1 and L2, and they're not horizontal or vertical, right? They're not going straight up and down, straight across. Are they perpendicular? And explain. Well, first thing is, do they look like they are? And they actually do look like they are to me because remember, you're forming 90-degree angles. But can you tell just by looking whether they're perpendicular? Nope, you can tell they intersect, but do they intersect at right angles, which is a very specific thing. And no, we can't actually tell that from looking at it. It could be close, but maybe not exactly right. So we have to actually compare their slopes. And when we do that, we calculate that line 1 has a slope of -3/2, and line 2 has a slope of +2/3. They're opposite signs, and they are reciprocals of each other. When you multiply them together, negative times positive is negative, and 3 times 2 is 6 over 2 times 3 is 6. 6 over 6 is 1, so -1. And so yes, the lines are perpendicular because when you multiply their slopes together, you get -1. Okay, you're going to try this with these two lines and demonstrate it, whether they're perpendicular or not. Explain how you know it. What is an equation of the line perpendicular to y equals 1/5 x plus 2 and contains this particular point, 15 comma -4? How can we do this? Well, you may recall this is similar to doing parallel lines, whereas parallel line, we said we can identify the slope from this line, and we use that same slope. We're going to do the same thing, except instead of using the same slope, we're going to use the opposite reciprocal. So we flip it, 1/5 becomes 5/1 or 5, and negating it is -5. So we're going to use a slope of -5 and this point, so we're going to have a slope and a point slope form. Okay. Identify the slope. And if you find the slope that you're looking for, essentially it's the negative reciprocal. You could do the math to calculate it, but you also don't need to do that. You just need to know how to find the negative reciprocal. And then you use point slope form. The slope you want to use is the negative reciprocal of 1/5 or -5. And then you plug in the x coordinate here and the y coordinate here. And then you just have to resolve this, subtracting a negative to be a positive. And that's in point slope form. And by the way, just fun fact, it says what is an equation, not the equation. The equation would suggest that there's only one. But when you say what's an equation, there's an infinite number of them because we could have always used just a different point that was on the line. And if you turned it into slope-intercept form, it would become the exact same equation. Okay, so different points would give you different point-slope equations, but they still are all describing the same line. So it just says an equation, meaning one of the many that you could write. So anyway, try this got it problem. Now this one's kind of cool because it's just a word problem, a visual problem for all of this. Okay, you're on the baseball field, and the field below it's got a coordinate grid overlaid on it. Okay, home plate is here at the origin, 0, 0. And if a batter hits a ground ball along the line shown here, this way, and there's a player here at 110, 70, okay, and that player runs along a path perpendicular to this path, essentially running as directly towards it as possible. What's the equation of the line on which the player runs? So we know that it contains this point, and if we know the slope of this line, then we can use the opposite reciprocal slope with this point and write the equation for it. We're going to do that on the next slide. I wanted you to see this big first. So what does this look like? Okay. Well, first of all, you want to find the slope of the ball's path, which if you calculate it using the two of the points you've got this point 30, 10, you've got this point 60, 20. You could have also used 0, 0. You'll see that it works out to be a slope of 1/3. Every one that you go up is 3 to the right. Okay, so it's got a slope of 1/3. Well, that means that you want to use the negative reciprocal, and the negative reciprocal of 1/3 is -3. So how do you use that? Well, which equation should you use? Well, we've got a point, we've got the slope, so we'll use point slope form. Okay, so we use the slope of -3, we use the point 110, 70, the x coordinate goes there after x minus, and the y coordinate goes after y minus. That's it, that's the equation. So now you've got to try yours where they ask you, suppose there's a second player at 90, 40, right here, and they miss the ball, turns around and runs in a path parallel to the baseball's path. What's the equation for that player's path? I'm hoping that this was a pretty straightforward lesson after you did the one where we reviewed everything from Algebra 1 about lines and their slopes. This one was a natural progression of that. So try these lesson check problems and see whether you do get them. Yeah, let me know if you need help. Good luck.